thinkers, let's take a look at another digital SAT question and how we can use Desmos to help us solve it. This question says, a cargo helicopter delivers only 100-pound packages and 120-pound packages. For each delivery trip, the helicopter must carry at least 10 packages, and the total weight of the packages can be at most 1,100 pounds. What is the maximum number of 120-pound packages that the helicopter can carry per trip? Lots of information here. I always like to start by defining my variables, and I do that by kind of reading through the information that I'm given here. I can tell that we're kind of dealing with two factors. We're dealing with the weight of these packages and then the number of packages that we have. And I can tell that I'm probably going to have a system of equations or inequalities here, just based on kind of the flavor of this SAT question. But let's start with just defining our variables for a second. So let's define X as the number of 100-pound packages here. And then similarly, we'll define Y as the number of 120-pound packages here. And then we're going to think about just what my inequalities could be based on the information that's given. I know that I'm going to have inequalities as opposed to equations because of the words like at most and at least. I know that I'm dealing with a situation where inequalities are going to be helpful to describe that information. So the first inequality I'm going to write is just by reading this kind of second sentence here. The helicopter must carry at least 10 packages. So some combination of X and Y, could be 10, could be 11, could be 12 packages total, but that's kind of what that equation or that inequality is representing. So I'm going to have X plus Y, so that total number of packages is going to be greater than or equal to 10. So it could be 10, could be 11, could be 12, has to be at least 10. And then the second part of the sentence, the total weight of the packages can be at most 1,100 pounds. Now we're getting into using the weight of these packages, and that's where I'm going to put a coefficient in front of my X and my Y because I'm trying to relate it to this total amount of pounds here. So I'll define that as 100X plus 120Y. This has to be less than or equal to 1,100 pounds. Can't be any greater than that. Where to assume we're in a helicopter, can't weigh any more than that. So now that we've done the work to create this system of linear inequalities, we're going to let Desmos do the hard part. We could definitely solve this by hand, but might as well use Desmos for this part here. We know that Desmos can't create this system for us. We have to do that part, but it can certainly help us with the finding of the solutions to this. So I'm going to type my first inequality here. The way that I get this symbol, I can come down here and use the keypad that's provided on Desmos, or I can use my own keyboard here by typing in the little symbol that's above the period and then hitting the equal sign to get this greater than or equal to 10. Now my second inequality is going to be 100x plus 120y. That has to be less than or equal to 1,100. And here I'm getting my solution set where these two inequalities overlap. We can see that part is kind of down here, the shaded purple and black part. But I'm looking for just the point of intersection that's going to make both of these inequalities true. So we can see that's where this point 5, 5 is happening. This is the greatest value, X and Y, that makes this situation true. So if I come back over to analyze the question for a second, what is the maximum number of 120-pound packages? We're looking for the maximum value of Y that will make this system of inequalities true. That's happening at this intersection point here, 5, 5. So I know that my answer should be C. Is there another question that you want to see? Make sure to leave a comment down below, and don't forget to like and follow our channel for more digital SAT content.